much, and like Ed, I don't like doing sums either. So, I'm a director for Mason Clark Associates. I'm based in England's finest historic city, which is, of course, thank you, York, that's right. And I'm going to be talking about this building, which is Victoria Mills in Grimsby, so just on the other side of the Humber from York. And this is possibly one of my favourite photographs of this fine building, which rises out of this sea of horrid modern development. So, a little bit of history for the building. It's a complex of flour mills, warehouses and offices. It was constructed between 1889 to 1906 and designed by Sir William Gelder of Hull, who went on to found Gelder and Kitchen, who are sadly no longer with us as consulting engineers. It was partially converted in the 1990s, and the 77 adjacent occupied flats in the lower development on either side of the central mill features quite strongly in this story, and it was 40 metres to the ridge, which is why I've entitled my talk Investigation, Monitoring and Repairs at Altitude, because 40 metres is a long way up to try and do anything. So just before I start, Ed said I would talk about the Conservation Accreditation Register for Engineers. So the idea behind this is it provides clients with engineers who are familiar with the philosophy and methods of the conservation of historic buildings as well as structures and sites. And it encourages us as engineers to raise our awareness and standards by pursuing continuous professional development in this area. All of the application process is through ICOMOS guidelines. So if you are IHBC members, it's a very, very similar process of going through case studies and producing a philosophy of conservation and so on. So I would like to say to the IHBC, I think I deserve free membership because I've done this through the engineers process. So, any time after this talk. So back to Victoria Mills. So here's some photographs before, while it was still an operational building. So the one on the left is up in the roof space, and what happened was a grain of flour was lifted up by conveyor and then tipped into these very tall bins, which were inside the main mill building. And that photograph on the right-hand side shows a forest of metal columns that was supporting the bins, and you can just about see on the right-hand side the chutes. So when they wanted to actually load up the lorries outside, they would open up the chutes and the grain would flow out into them for transport elsewhere. Now sadly, when I saw the building, it was in this state. So if we concentrate on the left-hand side, it's a complete open rectangle of masonry all the way up to the roof, 40 metres above me. It was slightly lower at the time because I was stood on at least 3 feet of compacted pigeon guano. So it was absolutely horrid in there. Wandering around the outside of the building, that middle photograph, I put a little white ring around some rather alarming cracking that went round all 4 of the turrets at the corners of the building. And if you look up at the top of the turret, there's an exciting little kink in it, sort of indicating that the turret's trying to peel away from the rest of the building. And remember that there are occupied people, there are people parking, there are people going to their homes on either side of these turrets, so rather alarming. And then that photograph on that right-hand side, that nasty green stain going down the edge of the turret. I shall come back to that. Is that overflow from the hoppers? What is it? So we couldn't tell from the ground, so we needed to go and find out. So just very quickly on the timeline of this project. So concerns were originally raised, and North East Lincolnshire Council and NG through Building Control and through the Conservation Officer team invited us in because parts of the roof of this building were actually blowing off and landing in the streets of Grimsby. which was clearly of concern. And also walking around the outside of the building, that photograph on the right-hand side, you can see fragments of brick and fragments of rubble and mortar falling to the ground from quite a long way in the air. And again, this is coming into occupied areas where people are parking. So there were concerns about this. We did a survey for the ground, and as engineers do, we recommended some monitoring, we recommended some investigation and some essential repairs to the fabric. But this is very difficult because all the bits of the building we were interested in were a very long way up in the air. So we started by recommending a drone survey, and I'll show you some of the photographs from the drone survey. But the drone, little 8-rotor copter, shown on the left-hand side. We had great fun whizzing that around the building. And then we did some limited high-level inspection using a mobile access platform in October 2015. We recommended a remote monitoring system, and then we had some sudden changes of readings from that monitoring system in 2016, and we had to evacuate the residents, and I'll tell you more about that story. And then finally we were able to scaffold the building and really get back in, do investigation, do emergency works, and then finally we could get on, supported by North East Lincolnshire Council, to actually get the scheme going with the skid works completed in June 2017. So starting with that drone survey, how useful was that to us? So this is the sort of photograph that we might see. So great, you can fly the drone up, you can buzz it around the outside of the building, you can clearly see some of the areas where the dormers of the building, the top left photo there, of something falling. You can understand why debris might be picked up by high winds and thrown about. But we're also starting to pick up some interesting raking cracks on the building, so it's very high, slender gables to either end of the main mill building. That's expressed on the outside, in the bottom left-hand side. We were even able to fly the drone inside the building with some trepidation, because it's an expensive bit of kit, but we could see those same raking cracks expressed on the inside. But probably the most of concern to me, on that bottom right-hand photograph, you can see those very unstable-looking bits of masonry just to the left of the turret. So why is there a gap there? Is that masonry stable? Is something about to collapse? What's going on there? Now, I'm a great believer in getting up close and personal to the bits of building that I want to work on. So I said, well, it's fine having this drone survey, but really I want to get close to these bits of masonry. So we hired a mobile access platform. A cherry picker is perhaps not a fair name for this. This was an enormous truck-based mobile access platform. When you're up at 40 metres, it looks very, very small and very far away. So I didn't dare lean over to photograph the truck. I just about managed to hold on and photograph the boom. But it does sway about in the wind, and it does sway about as you move about the platform. You need to be harnessed in. But at least it means you can get up close to the masonry. And one of the slightly surprising things was, when I got close to all of those areas of the parapets that looked in terrible condition, when we got close to them and you put your arms on them and you try to tug off bits of masonry, which is what engineers love to do, they wouldn't budge, which is great. Okay, so we still haven't explained why there's been cracks in the building. We haven't explained if there are other safety risks going on. But at least we felt that some of that worst cases of parapet masonry were at least sound for the time being. One of the worries, though, that we could see as we move back down the face of the building is the face of the brickwork, as you can see on that right-hand side photograph. It was starting to spoil. There were fragments of masonry just dropping to the ground all the time. And we used the opportunity with that cherry pick to actually brush off some of the dangerous, friable faces of the brickwork while we were working up there. And then moving on, we could see a rather nice roof garden growing up in the parapet gardens, which was intended to be there. And on the right-hand side, that green stain, which we thought was possibly just from the overflow, that's actually expanded foam. So that is a crack that's probably about 5 inches in width. And you could pick that green line stuck out with your fingernail. So you think that's going all the way down the building. What on earth is happening to the stability of the turret in the corner? So we then got some steeple jacks because we wanted to find out what was happening in the inside of the building. Now, this is where things really get exciting. So I've shown you the turret with a big crack on it with that big green expanding foam. When you look from the inside, you realise that all of the turrets have been constructed as a square cube of masonry, which is sat on some iron beams, which is balanced on a diagonal beam, which is then bearing into the masonry. Unfortunately, the masonry has got a dirty great crack in it that you can stick your fist into, and if you look closely, you can see that the turret steelwork doesn't quite bear on the steelwork. Almost as if it's teetering and about to topple off. So we were rather alarmed by that. The steeplejacks, you can just see a steeplejack's foot right at the top of that top right photograph. Quite a precarious place to be because that parapet gutter, amazingly, someone had managed to steal all the lead work, so very intrepid, courageous thieves in Grimsby, but the morning underneath was absolutely sodden and rotten, and your foot would go straight through that. And then at the bottom right hand side, that was our gables, that's the crack running up the underside of the roof line, and again, very alarming. There's clearly large amounts of masonry which are coming loose there. So we next recommended that we did some active monitoring of this building. We called in a company and we installed inclinometers and strain gauges over various sections of the turret and also on the highest gables, and they went up by cherry picker and installed all of this. And the idea behind this is that they send a signal through the mobile phone network, and the data is received remotely onto a website, and you can get a live feed of the information. And what does that give you? It gives you a load of wiggly lines, which is great, because engineers love wiggly lines, and we can correspond that to wind speed and temperature and various other environmental factors. But the important thing of this, working with North East Lincolnshire Council, we were able to establish the trigger levels. So we have movement on the turrets and movement on the gables related to wind speed, and we had a traffic light system, and we had a sort of amber light where we started to get concerned, and then we had a red light when we were really concerned, and we had a management plan in place to do something. And what was that doing something? Unfortunately, it's quite a political decision to make this, because during high winds in February 2016, we did actually make the decision to evacuate the flats in Grimsby. So that's 77 flats, all moved to temporary accommodation, I believe in the middle of the night, so again, quite a difficult thing to do. However, having made that decision, it also gave us the impetus and then the funding backed by the council to actually get on with the real works. So we were able to scaffold this building. I was quite impressed with the scaffolding until I saw that slide of the lights goes from the bar. So, it's a very pathetic height scaffold. Inside it was rather remarkable. It took a long time to walk up the staircase inside that internal scaffold. But it gave us wonderful access to all the sections of the building. And we were able to get up close to things like, up to this masonry. So we found that the purlins were actually bearing into the gable walls. The ends of the purlins were corroding, pushing those bricks out. That was reassuring to an extent, because we were worried that the purlins were actually separating from the ends of the buildings. But you can actually see on the ridge beam on that right-hand side, there's a double purlin there that looks very much like it's been squashed by pressure of the gables pushing against it. So you can see how they've bowed and gone banana-shaped. About this stage, we even had the Victorian Society getting involved. Griff Jones, no less, president of of the Victorian Society, wrote lots of worthy words about this project. He said, "I hope people living near these buildings will seize this opportunity and campaign to save them. Ultimately, it is the support of the local people which will ensure they are not lost forever." And I think particularly in places like Grimsby, which suffer from a lack of funding over time, those are particularly pertinent words. So the first thing we wanted to do, we wanted to make sure that the building was safe. We put in some emergency measures. So we thought a good idea would be to tie together the building from one end to the other. We put in some tie rods with some pattress plates that actually strap the two gables together. We also put in some corner protection, so we wrapped some cables all the way around the outside of the building with these steel corner pieces. These were holding the turrets together, and the idea was that as work proceeded on the building, we would be able to slowly lower these corner pieces down the building as things were made good. We did some investigation inside the building, so I felt that we might find some steelwork embedded in the brickwork. That entire 40-metre high structure had no embedded metalwork in it whatsoever, which was a surprise to me. We investigated the ends of the corroding purlins. We carried out some point cloud scanning, which was useful from a number of different ways. Firstly, we were able to make sure that the new pattress plates were installed in a position that was sympathetic to the final design of the building. It was also archaeological recording of the remaining industrial machinery found up in the roof. Then we installed some Syntec anchors. So these Syntec anchors, I believe there's a Syntex stand here today. So these are sock anchors that we use to hold the corners of the building together. So these are between 8 and 10 metres long, wrapping around the corners of the building. And finally, we were able to address that horrible green expanding field foam crack by making sure that we grabbed hold of that firmly. We installed new stainless steel bearing ends to the purlins, and then restored some of the timber infill packers to that. And we tried to leave as much of the original historic metal frame as we could. So here's our banana-shaped ridge purlins again. Now, instead of removing those, I just put some little inverted V braces on them, just to hold them together, prevent them moving in future. And all of that steelwork was cleaned, it was primed, repainted, and then we were able to start reassembling the timber structure in the outer part of the roof. We were able to take down the turrets, so there were terracotta domes on each of the turrets. These were carefully salvaged for reuse. We then took down the masonry of the turrets where it was all kinked and moved, and then we got down to the level of those teetering supports. We put in new stainless steel beams across the corners, and we actually strapped these down firmly to make sure they couldn't move in the future. And we put a vertical tie rod from the bottom of the turret right up to the top to clamp the whole structure together to make sure it couldn't start separating again. And then here's a photograph of the restoration of the dormers. So new boarding went on, which added racking resistance to the building. And then we put on the felt, the battens, and the original slate finish went back on. We were worried about the parapets because we believe they had moved under thermal effects. So we restrained those back to the iron frame, which I thought was rather neat. Just Pegram design pattress plates, those ones on the right hand side. We restrained that back to the iron frames. And we put the turrets back with a steel cruciform at the top of the turrets, and then the original terracotta units were reassembled back into place. And then finally, there's a photograph of the constructed corner of the building, and we've managed, unlike maybe Egg's barn, I think we wanted to make sure for public reassurance that there wasn't a kink in the top of that masonry. So yes, I think they did a good job on that with the contractor. And then finally we got some positive publicity out of all of this. So it was a very successful project in the end. We think we've got another 100 years of use, but of course the key thing for this building is now to find a sustainable future use for this magnificent structure. So thank you very much.